making a video for you about lesson 66, which is the one I assigned for the first section of this being out of school thing. I figured it'd be good for me to go over that with you. If you want to follow along, oh, by the way, this is for the Algebra half class, 7th and 8th graders. If you want to follow along with me, I'm on page 186 and 187 of your math book. Lesson 66 is called Changing Rates. Now, I already assigned this to you, but I understand that, got to cover a new lesson and figured you might have questions about this changing rate thing. So I'm going to look at the three examples on page 187 and going over that. Now, we've already discussed in class rate times time equals distance, which I have a formula up here written out for you. But also that includes rate times time equals number. In other words, in rate times time equals distance, if I go 50 miles per hour for 2 hours, that's my time, I'll get a distance of 100. In these problems, they're going to give you either the rate and the time and ask for the distance, or they're going to give you the rate and the distance and ask for the time, or they're going to give you the time and the distance and ask for the rate. You got to be able to figure out which one they want. If you will set up this problem every time, it will come out like you want it to, or it should. There's also rate times time equals number. If I can eat 3 Twinkies per hour, and I'm eating 3 Twinkies, by the way, I don't like Twinkies, 3 Twinkies per hour, and I eat for 5 hours, well, that's 3 times 5, that gives me 15 Twinkies. That sounds disgusting, personally, but I'd much prefer cookies. Chocolate chip, by the way, in case you're stuck at home trying out your baking skills. All right, so let's jump into this. I'm on page 187, this very first problem. It says Prince Charming, again it's Saxon, he always picks strange names and characters. Prince Charming traveled 60 leagues in 2 days. Right there, they give you the information you need. He's going to figure out what type of problem it is. This is going to be a rate times time equals distance problem. So the first thing you're going to do to work this out is write rate times time equals distance. Put that on your paper. Then it says he traveled 60 leagues. Is that his rate? Is that his time, or that is his distance? That is a distance. He traveled 60 leagues. By the way, a league is something like a mile. I don't know. I can't remember. It's irrelevant right now. But he did it in 2 days. Well, is 2 his rate or his time? It is his time. I go ahead and write the R for rate right here also. Rate times 2 equals 60. What's the one thing I don't know there? I don't know the rate. How do I get the rate by itself? Well, I can see right here that it is attached to this 2. Let's make this little X for a time sign. How do you get rate by itself? Well, how do you undo multiplication? Just like we've always done in class, we're going to divide. What am I going to divide by? Am I going to divide by R? Am I going to divide by 2? Am I going to divide by 60? Again, what is the R attached to? It is attached to this number 2. The number 2 is what we've got to get rid of. So we're going to divide by 2. I'm going to divide by 2 on the left-hand side of the problem, and I'm going to divide by 2 on the right-hand side of the problem. These 2's cancel, and I get the rate is 30. That means he's done 30 leagues per hour. Now that's not the final question. If that was the question, how far can he go in an hour? Your answer would be 30 leagues per hour. But it says, the title of this lesson is Changing Rates. Look at the next sentence. I'll start from the beginning. It says, Prince Charming traveled 60 leagues in 2 days. It was days, not hours, sorry. Okay, so I told him find his rate. That means he can go 30 leagues in a day. Then he doubled his rate. If I'm going 50 miles per hour and I double my rate, I'm now going 100 miles per hour. If I'm eating 3 Twinkies in an hour, and I'm going to double that, well, that means I can now eat 6 Twinkies in an hour. So here's the rate he had originally. He's going to double it. What does it mean to double it? Well, that means to multiply it by 2. And his new rate is 60. He's now doing 60 leagues per day. How long, the question is, how long would it take him to go 300 leagues at this new speed? Again, you're going to write up another rate times time equals distance. This is the new rate. It says how far, I'm just going to read it again. I'm sorry. How long would it take him to go 300 leagues? How long? That's a question of time. You don't know the time, so I'm going to put a T there. His new rate is 60. 60 times that T, and his distance is going to be 300. How long is it going to take him to go 300 leagues? Well, I don't know. How do you get this T by itself? Well, it's attached to this 60 by multiplication. Over here, this 2 and this rate were attached by multiplication. How do we get them apart? We divide it by 2. Likewise, over on this side, I'm going to divide by 60, the number that is attached to time. And since I divide by 60 on this side of the problem, I must divide by 60 over there also. These 60s cancel, leaving just the letter T. And 300 divided by 60 is the same as 30 divided by 6. His time is 5. He changed his rate here, and we were able to, we changed the rate, and so he was doing 60 rather than 30. Okay, so let's move to the second problem. The second problem is a rate times time equals number problem. I'm doing 62.2 in the middle of page 187. It says the machine could cap 500 bottles in 2 hours. Rate times time equals number. What does it say? It could do 500 bottles. Is that its rate? Is that its time? Or is that how many bottles it could do? Well, that's the number of bottles it could do in 2 hours. We need to find the rate. This is very similar to that last problem, except for it's dealing with bottles rather than leagues. We're going to divide both sides by 2. This machine can bottle 250 bottles in an hour, or cap them, I should say. All right. If the rate of the machine was triple, well, here's its rate right now. They're going to crank this baby up. They're going to speed it up, and they're going to crank it up by a factor of 3. Its new rate is going to be 750. That's the new rate that we're going to use in the second problem. I'm going to move this over a little bit so we're not on the edge so much. Okay. Now what's the question? It says, how many bottles could be capped in 10 hours at the new rate? Well, again, we're going to put up another rate times time equals number. This rate that we got, the new rate, is going to be used right here, 750. And they say, how many could it do in, what was it? 10 hours. The 750 and the 10 are already together, and we're looking for number. Number is all by itself. We do not have to move any numbers. All I have to do is crunch the numbers that are already there, and 750 times 10 gives me 7,500. That tells me this machine can do 7,500 bottles in an hour at its new rate. Relatively simple. Just Set up your equation, find the new rate, plug it back in. Each time, writing up rate times time equals number, or rate times time equals distance. One more. The third example, bottom of page 187. It says vacuous. It's Saxon, remember? He's got those stupid names. No offense, Saxon. Vacuous ran 6 miles in 2 hours. This is a rate times time equals distance. He ran how far? 6 miles. That's his distance in 2 hours. What do we not know? We don't know what the rate is. It's pretty simple to figure out. We show our work even on the simple problems, because sometimes you're not going to be able to figure them out just by doing them in your head. You got to show the work. He's going 3 miles per hour. Okay? Then he ran 20 miles in 4 hours. Notice this is not a change of rate. It's a totally different problem. That's a rate times time equals distance. And it says he went 20 miles in 4 hours. Well, trying to get rate by itself. The rate in this one is 5. Basically, it's like he's running a race and he did it in two different sections. The first time he's running at 3 miles per hour, and then he's running at 5 miles per hour. Look at the question. It's not what is 3 times 5. The question is, by how much did his rate increase? In other words, what's the difference between these two? How much faster did he go? Well, if I'm going 3 miles per hour and then I'm going for 5 miles per hour, and I got to figure out, well, what's the difference? Well, let me see. Carry 3 divided by 7. Oh, that's easy. That's simply 5 minus 3. The difference is 2. Now, if you have any questions on any of the other problems I assigned, I gave you that sheet of paper that had hints on how to do them. Please drop me an email, text me. Your parents know my number. Give me a call. I don't mind, on my cell phone or at home. And let's get through this together. Hope to see you guys soon. God bless you.